Hey guys, in this one we are doing more probability tree diagram questions. Let's go. Number 1. 2 ordinary fair dice are rolled. Complete the tree diagram. Alright, so our 2 events are less than 3 and 3 or more. So, on a normal dice, 2 numbers are less than 3 out of 6 possible numbers. So the probability of less than 3 is 2 out of 6, or 1/3. So the probability of 3 or more is 4 out of 6, or 2/3. Now the probabilities are the same on both dice. The second dice does not depend on what happens on the first dice. Here in part B, work out the probability both dice land on a number less than 3. So we want less than 3 and then less than 3. So when we go along the branches, we multiply the probabilities together. So this is 1/3 times 1/3. And that is 1/9. And then we want to work out the probability exactly 1 dice lands on a number less than 3. So that means we either want less than 3 and then 3 or more, or 3 or more and then less than 3. So now we have 2 probabilities to work out, and then we add them together. So we're going to have 1/3 times 2/3. Add 2/3 times 1/3. Now that is 2/9. Add 2/9. And that is 4/9. Number 2. Anna plays a game with an ordinary fair dice. If she rolls a 1, she wins. 2 or 3, she loses. 4, 5 or 6, she rolls again. When she rolls again, if she gets odd, she wins. Even, she loses. Part A. Complete the tree. Alright. So, the probability of getting 1 is 1/6. 2 or 3 is 2/6 or 1/3. 4, 5 or 6 is 3/6, so that's 1/2. And then when she rolls again, half the numbers are odd and half are even. At B, is Anna more likely to win or lose? You must work out the probability she wins. Alright, so the probability she wins. Let's have a look. So, if she gets a 1 on the first dice, she wins. So we want that. Now, she can also win by rolling 4, 5 or 6 and then an odd number. So, the probabilities we want are 1/6 add. Now again, we're going along branches, so we multiply. So this is add 1/2 times 1/2. So that is 1/6 and 1/4. Alright, now to add those, we need common denominators, so we can turn them both into 12s. So this is 2 12s. Add 3 12s, which is 5 12s. So the probability of her winning is 5 12s. So the probability of losing is 7 12s. So she's more likely to lose. Next up, a darts team is going to play a match on Saturday and on Sunday. The probability they win on Saturday is 0.45. If they win on Saturday, the probability they win on Sunday is 0.67, and if they do not win on Saturday, the probability they win on Sunday is 0.35. Part A, complete the tree. Alright, so this one is dependent probability. What happens on Saturday affects what happens on Sunday. So, probability always adds to 1. So, on Saturday, the probability they do not win is 0.55. Now, if they win on Saturday, the probability they win on Sunday is 0.67. So the probability they do not win is 0.33. Now, if they did not win on Saturday, the probability they win is 0.35 on Sunday. So the probability they do not win is 0.65. Okay, then part B, on to find probability they win exactly one of their matches. So, we want win and not win. And not win a win. So, win and not win is 0.45 times 0.33. And then we add the probability of not win. So that's 0.55 times 0.35. And that gives us 0.341. Next up, when a biased dice is thrown, the probability it lands on 4 is 0.65. The dice is thrown twice. Amir draws this probability tree diagram, and we're told it's not correct. So we're asked to find two things wrong with the diagram. Alright, so on the first tree, the probabilities don't add up to 1. So is probability 4 not land on 4 is wrong. So it shouldn't be 0.25, it should be 0.35. Okay, then if we look up here, he's now got these two probabilities the wrong way around. So land on 4 is 0.65, not land on 4 should be 0.35. He has though managed to get things right on this bottom tree, so well done, Amir, sort of. Final question, so Amina has 2 bags. In the first bag there are 3 red and 7 green balls. In the second bag there are 5 red and 4 green balls. She takes at random a ball from bag A and then a ball from bag B. But A wants us to complete the tree. Alright, so because we're picking balls from different bags, whatever we do in bag A, or the first bag, does not affect the second bag. So this is independent probability. So, in the first bag, red is 3 out of 10, so green is 7 out of 10. Now, in the second bag, red is 5 out of 9, so green is 4 out of 9. And those two are the same down here. Again, because the bags are independent. Okay, then part B wants us to work out the probability she takes 2 Red Bulls. Alright, so the path we want is red, red. So again, we multiply along the branches. So this is 3/10 times 5/9. So on top, that's 15. On the bottom, that's 90. Now that would be fine, but it also simplifies to 1/6. Alright guys, that's the end of that one. Really hope it's helped. Take it easy. Take care.